There are 5 specific AI skills that decide whether you get hired as a software engineer in 2026 or spend another year sending applications into a void. And most developers right now are missing 4 of them. I'm a software engineer turned AI engineer who got recruiter messages from Apple, Meta, Netflix, and Amazon without applying. And it wasn't talent or luck. It's because I built the exact skill stack hiring managers are quietly filtering for in 2026. In this video, I'm going to break down all 5 of those skills in order, why missing even one of them is putting you at the bottom of the resume pile, and why the developers who lock these in over the next 12 months are going to leave everyone else behind. Let's get into it. You see, the problem right now is that the bar keeps moving. AI requirement is pretty much everywhere. It's not just in deep tech anymore. It's also in every aspect of any type of business. Even your local business uses it. And the roles change very fast. Jobs now demand AI skills. You'll see job postings that you were actually qualified for now redesign or repurpose now, including AI aspects of it. And a lot of people are feeling left behind without a clear direction because they don't even know what they're being left behind on. And the other thing is there's bad advice everywhere because the generic term is just learn AI. What does that actually mean? So the real problem is there's no clear roadmap, no clear learning order and what to order, what to learn at all specifically. And most content online sends people down the wrong direction. So the purpose of this video is to give you the list that nobody actually gave you. So here's how I want you to reframe and think about how it should be approached right now. See, in 2026, hiring has changed. Good developer, being a good developer, just knowing how to code and be good at that alone isn't enough anymore. Hiring managers want a specific AI stack. So the thing is, not only that, the actual stack matters. And there's 5 connected skills. And I want to emphasize the part connected over here skills because the order matters. Each skill builds on the next one. So once you learn skill 1, that is a foundation for skill 2. And the skill 2 is the foundation for skill 3 and so on. If you skip the order, what's going to happen is your portfolio is going to look busy and you're still going to get no interviews because you're not actually showing the higher level stuff, but you need to know the foundational things under it. So there is a correct sequence that part creates a real leverage because what's happening right now are even when people do projects or even do other guided tutorials, they're telling him go here, click here, and they might have something working at the end, but they don't understand what's happening. They don't know why it's happening. So if they're given a real world scenario, they don't know how to put it all together. That's why you have to build all these skills in order. So you know underlaying the foundation what's actually happening. So when you come with a new real world problem, you know how to actually approach it and solve it. How personally I discovered this path? Well, I built this stack personally myself in this exact order. And the main thing about this, I use just-in-time learning. Basically, learn what I need at the time I need it, and not try to go down a rabbit hole and learn everything. And I only focus on the outcomes, and basically identify what the goal and what the outcome is at first, and then figure out reverse engineering and figure out what are the steps I need, and use just-in-time learning to learn that section. That's how I got to the end goal there. And that basically made the timeline compress really, really fast because it took months and not years because I was only focusing on what's needed to move to the next step. And the results basically followed afterwards. I got AI offers. I got patents because I was actually solving real world problems. And how I knew what the real world problems were because I defined what the outcomes were and what the definition of success was supposed to be. And the important point to make here is that this is not talent based. This is the real advantage. It's actually repeatable. If you follow the same order of operations, you'll get the same type of results. Skill number 1. This is the first skill you should highly learn right now. And that is Python and the language to learn that. That's basically the foundation language that the entire AI ecosystem is built on. Not because it's the best and not because AI can't be done in any other language. In fact, 10 years ago, we just had the theory and papers and the math, and it was up to you to implement it. So it was done in every other language. It's just as things evolve, like TensorFlow came out, PyTorch came out, TensorFlow was from Google, PyTorch was from Meta or Facebook, and they're in Python. And that kind of became the de facto of the industry. So that's why it matters because every AI framework now is kind of by default, by default goes to that language. And pretty much if you're going to go use another language, you have to go through the extra overhead of converting code or understanding frameworks that already exist or models that already exist and convert it to another one. So it really doesn't matter if you already know JavaScript, Java, or Go developer. If you are a Go developer yourself, you should learn Python just for the fact that so you could interact with the the what's AI current tech stack at the moment. And the main things you need to learn, because you don't want to go down and learn every little thing in Python, is basically the core syntax, data structures, APIs, how to work with a virtual environments with it. So every time you do a new project, you don't mess up your current code base, because you have a specific version. You can make virtual environments that is set up specifically for each project. And basic object oriented programming, or OOP, for object oriented programming. And the goal is basically to read and build the AI code. So we understand it and you understand what they're talking about because you're speaking the same language. And the things you want to skip is Django and doing deep dives in that, Flask, and basically anything that's Python web development. That is, we're dealing specifically for the AI portion of it. Python is a general purpose language that could do many things. You can do web development, you can do games, you can do AI. And if you start looking into that, because it's so broad, you'll go down rabbit holes forever. You want to focus on these things here to basically streamline your learning curve for streamline the learning process and minimize the learning curve as much as possible for AI. So again, very important consequence here. If you skip Python, you're pretty much locked out later because, as I mentioned before, skill 1 is the foundation for skill 2. Skill 2 is the foundation for skill 3, etc. So if you don't have a good foundation, the other things won't really. It'll be a lot harder and a lot more friction to learn. Skill number 2 that you learn on this path here is ML and data science stack. So that it consists of the foundation of AI. That's basically the data science, the data, and the models. Why hiring managers actually care about this? Because they want, even though you don't actually going to actually train a model from scratch or build a model architecture, code it from scratch, you want to know they understand what's under the hood. And so that's the main difference between uses AI and actually build AI, because you actually understand what's actually happening. And what are the tools you need to learn for these things? This is pandas. Think of this as kind of like doing Excel, a spreadsheet, but in code. That's kind of a simplified version of it. NumPy, doing numerical Python. That is basically crunching numbers, a high computation. That's what allows basically Python to do that. If you know, Python is a general purpose language, which is great for convenience. One of the problems of setback behind it is the speed of which it calculates. So if you try to do math with just pure Python, it's really slow. But with NumPy, it's actually pretty efficient with that. Then Jupyter, that's a way you could actually, it's more modern, what you call literate programming, where basically you have the documentation is the code. So think of it as if you have a Word document explaining things, like in a textbook, and then after they have like a snippet of code. In the Jupyter notebook, you could actually execute the code. So imagine if you have your textbook where you have give an example of a code, but you can actually execute the code. And then Matplotlib, so you can visualize. And scikit-learn is pretty much have a lot of the ML algorithms, statistical algorithms already built in within here. And a lot of machine learning algorithms already come with this. So you don't have to implement it from scratch. A lot of the classical ones, right? And then after that, you want to learn the deep learning framework, which basically is a model architecture, a neural network. And in terms of the naming, if it's called deep if you have more than 2 layers, but the preferred framework right now is PyTorch. That is used by default usually when new papers or new architectures come out. An important rule is pick one framework, because there's probably 2 main ones I would say right now: TensorFlow and PyTorch. PyTorch is more Pythonic, and pretty much now the de facto everyone writes in PyTorch. But a lot of times it's like the MVP, or not the MVP, like the prototype version or the research version of it. A lot of times when you go into production, TensorFlow has more optimized versions of it where you can actually bring in production. But I wouldn't worry about that. That's more of the technical details. If I had to choose one, I would suggest PyTorch at the moment right now. And then you'll skip these mistakes. Do not go down pure math rabbit holes to learn everything, how to derive, basically learn everything with calculus and as well as like statistical model and linear algebra. And plus you can go down that forever, down these rabbit holes. We're not trying to be a researcher. If you're going to be a researcher and want to go into academia, that is the path you're taking. you're trying to get results, you just need to understand what is happening. You don't have to be a math major, uh, post grad level, like PhD level. Basically, this is where just in time learning, learn what you need to apply here and move on to the next stage. So because we want to build while we learn, and we already set the outcome. That's why working with actual business, you know what the outcome, what the definition of success is supposed to be, and you work backwards to set up the steps and learn all the pieces for the steps to actually achieve this. And the thing is, if you don't learn all these things, so the science, the ML, the data stack, uh, the ML and data stack itself, you're pretty much just becoming a prompt engineer. And when prompt engineering was first introduced as a job, yes, it was deemed very valuable. But now there's a ceiling because the people realize you need more people actually know some actual engineering or technical engineering, not just how to set a prompt to the LLM. Skill number three are basically LLMs, large language models, and RAG, which is retrieval augmented generation. Right now, it is the highest demand AI skill. And I can say this for a fact, a lot of the projects I work on for companies always involve LLM and RAG. This combined is really, really helpful for companies. Why? Because without this, if you're just basing on the data that the large language models are trained on and not specific to the companies or your project or whatever data source you want to source from, then it would hallucinate answers that it doesn't know. And also, it doesn't know the specifics of the company, right? This is why what companies really want AI with company data. And this is also why it's super important, or basically the reason why that, like, when people originally think of AI in companies, they think of the deep tech, very tech oriented companies, and in Silicon Valley, and every company could use AI right now, mainly so they could use it to work on their own company data itself. That's what makes it compelling, and this is why it's high in demand at the moment. That's why it matters, because most AI products use this now. They're like, oh well, we could use AI and then adapt it to our company data. That's great. And specifically, you want to use LLM APIs. So if you're using already things like GPT, or Chat GPT or GPT in general, Claude, as well as like Llama from Facebook, so you can have off local models, so you don't have to go to the internet, use tokens for that. And prompt engineering is actually helpful. I have built systems with it and using local models, and use prompt engineering, but it's at the engineering level, mainly to process. Is a lot easier to interpret data, conform it, using prompt engineering, and basically ensure that it conform correctly to what it needed. This is this is not like Twitter level of prompting, and then also understand the concepts of embeddings and vector databases. High level, the concept of it, you don't necessarily have to go down and code your own transformer architecture from beginning to end, and understand how to do end-to-end RAG pipelines. Again, this is what companies want: LLMs and RAG systems. So I would highly focus on that. Skip these things: training LLMs from scratch and transformer math obsession. Unless you want to be a researcher, this this is you don't need to know. You don't have to build the things under the hood. They exist already. You need to know how to use them, because companies, this is what they want. That's companies want this stuff, right? Core strategy mainly. And if you do want to learn this on your own time, I would say build first, get it working end to end, have what I call a baseline that everything's working. And then if you want to go even deeper for your understanding of it, learn deeper later, instead of going, in the tech world, instead of it's breadth first versus depth first, right? Make sure you cover everything, and then only go in depth for things you need. And maybe on certain projects, you might need to understand something a little more because of the nature of the project, but get something working first. And the market reality right now is this is what gets interviews, because they want to see companies care of, okay, how using LLMs and RAGs, how does this AI work for me? And it doesn't have to be deep tech. Any company now can start using this because they want to get insights on their own company data. That's what makes it so important right now. Skill for agentic workflows and LangChain. Basically, the next evolution of AI are base agents that actually take action, not just respond to uh, what's been interacted with. So beyond chatbots, you want them to be able to do planning, use other tools, and actually do multi-step execution over here. So basically, when This is where the industry is going right now. Agent doesn't just respond; it actually does something, and specifically learn LangChain, tool calling, agent workflows, safe tool access, and pipeline orchestration. This is where the value is, and this is how you're going to map what the tools can do or what you have available to the business needs to get the final results of the business outcome, which is what business care for. And these are the same things you want to skip, basically chasing every single framework. Choose one once it starts working, get it to work from there. You don't This is what the companies want to see. They're under the hood. They don't care which framework you use. So basically, once you get one that basically does the job, follow through with that. And the other thing to skip, don't try to be perfect before actually shipping something. Get something working and then iterate and improve upon it. That is the much better solution. Remember, the best thing is to do is pick one stack, one that you know that works, ship a real project. And in general, in real world scenarios, you're building out or you're solving problems or you're building solutions for things that probably haven't been done before. So try to get it perfect from the beginning is not realistic. Pick one, get it shipped, and then go back and reassess and reevaluate, do a postmortem, figure out what you need to improve, and do another iteration. That's why software has many different versions, is because they have a version that works. Once they put it in the wild and they start seeing how it's being interacted with, they're like, take notes. Let's change these features or add new ones to make an even better version. And that's why I have a lot of iterations, a lot of versions. You never see one release, at least nowadays, one release and that's it. They, basically hit a real home run from the first swing. So you want to take it that way, like get something working, move out. Don't aim for perfection, right? Aim for progress. And basically, future engineers, senior engineers are the ones who actually build agents. That is the how it works at the moment. Skill five, and I would say it was probably the one that everyone skipped and is the most important one, deployment and production. Basically is DevOps for AI. I would say this is the missing layer, having a production deployment. Even researchers, a lot of them don't know how to take their work, even if it's blue sky or is innovative, how to actually deploy that in actual production. And this is what hiring managers want: shipped AI projects. Keyword here is ship, right? Not just something that works in a Jupyter notebook. That's not enough anymore. And that's what used to happen in the past is when they were thinking of AI, the only people who knew AI were pretty much the researchers. So companies would hire them and they'll build their things in like Jupyter notebooks or whatever prototyping version they had no idea how to map that into an actual product for deployment. They weren't trained on how to do that. And that's where the gap that people who did know how to deploy software didn't know AI and didn't know how to link them. That's why knowing these two DevOps for AI itself is what makes you valuable. So learn these things specifically. Fast API, so you're able to use REST API and be able to talk to each other. An alternative for this is Flask, which is a Python module or package that allows you to do this as well. Then there's Docker. That's to containerize it, so you can put everything in a container and you'll avoid the problem of, well, this works on my computer. Once you put it in a container, then you can start deploying it locally or on the cloud, such as AWS or Google Cloud platform. Again, just have one cloud only. You don't want to basically say that you're like a cloud engineer. I mean, if you are, that's great, but your goal is not to become like the greatest cloud engineer. You want to be able to deploy it and then even to work with others cloud engineers once you have it working and have the maps, like all the piping working correctly, then you could actually like scale up on this. So skip, using Kubernetes too early or unnecessary certifications. The certifications at this point don't matter. They want to prove that you could actually ship AI products. So remember that, ship AI products. The biggest difference between a notebook versus a real product, notebook, I mean, that's cool. It's like a demo kind of thing. And most likely nobody else, unless you work in the space, know how to use it. A real product is designed to be user facing, the front facing. And once you see it working, they believe it. That's what you want to be able to do. That is basically what Closes offers, and having working deployable system, a real world project, real world application. That is what makes people believe you could get the job done. These are the questions most people have. First question is, they'll basically say, well, that's a lot to learn. Well, yes, it is. There are things you have to learn, but it's less than it actually looks because each one builds on the other. And it's not like you have to learn everything as if you're doing a whole computer science degree. And this is basically doing it this way by have just in time learning. The timeline is compressed because the skills build together. Once you learn one thing, again, skill one is a foundation of skill two is a foundation of skill three. You're building on top of it. So when you actually start doing it, the main goal is to get to the end of it, like the top skill, like skill five. But understanding skill four, skill three, skill two, skill one is really to help the understanding the skill of skill five a lot easier. Because in the end of the day, you're not actually doing the actual coding from skill one, skill two, skill three, skill four. It's for you to understand it. So when you get to the top level, higher level stuff, you know what they mean and you know what to orchestrate and what configurations you need to change and whatnot. These again, not separate topics; they're all connected. That's what makes it less than it looks. Um, and and the way other question people might ask is, what if AI changes? Yes, the tools itself, the details actually do change over time, but the strategies don't really. Like there's the concept of principles, strategies, and tactics. The principle is like the one main goal that you try to do, like the company, let's say, could say like be the best uh I don't know, like whatever product they're building out, like the best tech company in this space, right? And then the strategies are pretty much the guiding how you're going to be doing this stuff. Now, the tactics are the actual details of how you execute it. So this year it might be using some specific tool. The next year it might be another tool, but the strategy doesn't change, right? The structure that remains the same. So when you learn how to do that, you pretty much you build it, and then you just update what's changed over time instead of doing it from scratch and learning over and over again. What basically stays constant: Python, machine learning, LLMs, agent deployment. These pretty much stay the same. Now the details of what you're using might change over time, and we have seen it change over time, but these pretty much stay the same. The key advantage of this, as I mentioned earlier, is just updating the skills. So if you have a certain pipeline going from one to the other over here, and then this thing changes over time, well, you just update this, but the rest of the pipeline doesn't go out. It just stays where it is. You basically that stays constant. And if something this changes, then you swap that out. But the main strategies, the main structure relatively remains the same. So it's not restarting like you're restarting your career. You have to learn everything all over again. You already know the foundational and the stuff, and you're just updating what changes and to stay up to the time. I want to stress why this matters right now at this specific time, because developers who are landing 200K plus roles at this moment, 2026, have this stack, this tech stack. They know it. While other developers are struggling, who are applying for roles and they're just applying to many and many, and they're just going into the void, they still are using pretty much a 2022 resume. And the thing is, at this moment, because AI is so new and people don't know how to approach it, the current opportunity gap is where it is right now. So it's only a few months of focus to just get the required skills to have these type of opportunities. Now, the thing is, in the future, it's going to become years of pretty much the skills you have to fill that gap. That is pretty much the future reality. And the important thing about this is that this is going what you learn this gap right now, where there's an arbitrage, there's a difference where people don't know how to use it right now, and that's why you're getting higher opportunities. That's going to become the standard that always does in the near future. So the real advantage is getting in early so you can actually become sooners, become like seniors in this space as it move forward and take advantage of it before it gets crowded and becomes the norm and it becomes a lot more difficult to get in. Your next steps right now, if you want the exact roadmap, the link is in the description. What it includes is a full 6-step program. And built into this system itself is the real world portfolio projects and job hunt strategy. And what this aims for are what currently positions are posting for that basically satisfy the 200K for AI offers right now.